Hello and welcome back. Today I have a frequency counter and it is the Racal dana and it's the 1998. And a month ago I think I showed the 1992 that was also 1.3 gigahertz. The only difference is with this one it is a little bit newer, and the 1998 has an extra digit to show. The 1992 had 9 digits and a little exponential digit. This one has the full 10 digits, and also it has the option A4 or 4A, which means it has a better oscillator. So we can also see the difference because they are interchangeable. So I can take them out and we can have a look side by side. So let's have a look. So this is the 92. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a smaller exponential one. But here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. Both go to 1.3 gigahertz. And this one also, but extra digit is of course great. Here we have a lot of buttons, and they minimized it here already a lot. We can still do the ratio AB as we have here, and the only thing, this one has an extra channel. This only has A and B. This one is A, B, and C, and you can do a lot more combinations with the ratios that this one doesn't have, but it's newer. Also the option with this better oscillator. So I will put my power meter in between. This is just on the mains, so we can have a little look. Yeah, if it is ovenized, if the oven switches on and off, and how much power it takes. And I think then the 1992 with the simple oscillator should take less power. Quickly the 1992, and it takes about 17 watts, 18 watts. And that's it, it's not ovenized, so the power will stay more or less the same. So now it's interesting to see, because I know from my Philips, I have here the bigger one. Is it the 6685? And that one takes about 70 watts in standby. So that is clearly the oven. So let me see in this one, and even if well, you can't switch it off, it's always in standby. So it's just all the time, even though it's running on external reference, it's always taking 70 watts. This one, when it is switched off, I see it is really switched off. So when we switch it on, we see it is taking the same, also like this. 18 watts, it's actually using less. That's interesting with this oven. And in standby, I think then the oscillator keeps running. It's about 6 watts. So they made it a lot more energy efficient, the 1998. Interesting, didn't expect that. But I will have it switched on for a while, and then at some point this should probably drop when it is up to temperature. And well, just we can play a little bit with it. See if it is properly adjusted or not. Put my reference. They should match now about to 10, but as we can see, it is still heating because the frequency is slowly getting there, and this hasn't dropped too much. So I expect it later to be lower. It dropped down to 13, and then it had some overshoot, and it is now already regulating, and that is in 5 minutes. So now we will see again that it goes a little bit too high, and then we will see this one drop again. But it's reasonable stable now, because it went up and then it went down again. And now we are again lower, and now it starts to heat again. It's kind of thermostatic. We are now about 10 minutes, And we see now that the watts or the current stays a little bit around these values now. And this one is also going a little bit from 89 to 10, and it seems to be more and more stable already. But probably if we look in the documentation, they say you need to have it for half an hour or an hour. But I already see that it is now trying to stabilize it, and we just need to adjust it a little bit. So let's have a look while it's still on. Have a look at some of the options. We have two inputs. The A input is up to 160 megahertz, and the B input is starting from 40 all the way up to 1300. And we saw already with 1992 that we had that we could push it almost to 1.6, I think, if I remember correct. And well, it seems to be very easy to work with. We can add here a digit if we want. We can do less. And the more we add, the slower the gate time also becomes. And we change here with the numbers from the B to the A input. We can measure the period time. 10 megahertz would be so many nanoseconds. We have to check it is just a loopback test on its own oscillator, which of course comparing it to yourself will always be correct. Then we have an AD ratio. I do not know what that is because we do not have a D channel, but maybe that is a connection in the back. And we have a BA ratio, the ratio between the two, but I have nothing connected here. Go back to the frequency. We have an attenuator. If we have too much signal, we can try to make that lower. Well, it's loud enough, so that is no problem right now. There is a filter that is usually for lower frequencies that you can get your harmonics out. And we have the 50 ohms if we want, or the high impedance. And this one is always 50 ohms because it is the prescaler. Okay, we are almost 10-15 minutes. I didn't put the stopwatch, but I would say 10-15 minutes. And well, the current is more or less stable now. And we see also that the frequency is now all the time 70, 71, and we are 1, 2, 3, 1, 2, 3. So we are below the hertzes already. So it is reasonable spot on, but it's also stable because even though this goes a little bit, so I think the modulating is done, or it found is stable, and it just stays around this 70. Well, it stayed a long time in the 9971 or around that 70, but then I left it on for more than an hour, and then it still was dropping. But it is not completely fair because also in the lab, well, now it's 19, but in that time it was almost 25. So also the whole workshop here is going up and down in temperature. You can have a look around. Well, it's exactly like the 1992. Only here in the back we have some extras. This is different. You can see the oscillator is much further in the back. It is already set to 240, that is correct. And we have here the option 04A. So let's have a look. I think it's true because the oscillator is a lot further away than the little one I had in the other. Yeah, even though it's only 5 years in between, it looks a lot more modern. Look at this, the oscillator. A lot bigger than the standard. These are a little bit bulky. And, well, again, the prescaler right here. But this one is a lot more covered in metal, so this is an improvement. And the rest, yeah, instead of a lot of loose ICs, we just have a few big ones. Let's have another look at the oscillator. Look at this, how big this is. I think it's 6-7 centimeters. Yes, it is 6 by 2 inches, 5 centimeters. It is a lot bigger than the one from the 1992, which was the standard. I can compare it. I will open the other one also. So here is the other one, the 1992 with the default oscillator, just a little PCB with, I think it was sort of a crystal or a little oscillator block. I have a separate picture from that. Then look at this. What a big difference between the standard oscillator and this overniced A4 option or 4A option. I really wonder what even better. There is also a 4B oscillator, so maybe I will have a look at that also once. Well, now I have them here, and I had the feeling somehow that the left, the 1998, was a lot more modern also on the mainboard. But it doesn't seem to be. If I look now, they are very, very similar. Only somehow the power it uses is a lot less. Well, this one, the 1992, had a GPIB board, and this one doesn't. Maybe it's interchangeable, I don't know, something to try. But this one is taking a lot more power than the 1998 here, but it looks very similar, the boards. This is the prescaler from the 1998, and this is what the prescaler looked of the 1992. When we have a closer look at the whole oscillator block, we have here this whole oven thing, where probably the crystal is, but here we have the oscillating module, and here we also have 2 coils that we can adjust. This is not for the frequency. I think this is for the amplitude, just to have it oscillating. And then we have another screw inside. I hope I can do it with this one, because it seems I need a very long shaft. So I hope I can make it. But let's first, I will put there the oscilloscope to see if it's oscillating to its maximum. So we have the oscilloscope right here. I will measure on the pin that go to the PCB. That is usually TTL or at least high level, so the impedance here would not matter all that much. So if I measure here, it says it is exactly 10 megahertz right now compared to my oscilloscope. But we will see once I start adjusting here that it is purely amplitude and not frequency. So we will get this to maximum and as stable as possible. Well, that would be this. I must say it was already good. Oh. This seems now I do frequency. I use this ceramic screwdriver. Let me see if we can. Okay, that's it. I use these. These are better than the darker blue. And well, it's still heating a bit. Well, there are 2 methods to adjust. You can adjust in the front here, depending also on the amount of digits you have available, or you can measure the internal oscillator. Here, I connected it to the external output, and well, you can see here if the internal runs a little bit too fast, it has not enough time to count, so that means you will miss counts. That is here. And if the internal oscillator runs a little bit slower, it can do more counts, and then you will see it higher. And well, we can see exactly this digit is missing here, so that is correct. And we try to get both, of course, as close as possible. Well, I think this is reasonably good. I can do an extra digit here, 2 digits extra even. but we are already far below the hertz. 1, 2, 3, 1, 2, 3, 9, 5. So this is very, very low, and here we see the same. Okay, I leave it as it is now. Look at that. Perfect. Okay, this is as good as we can get it with this internal oscillator, but we are already here in the millihertz, so that is good enough for a frequency counter. Just using it as it is now, mobile. Of course, I would normally connect it to my external reference, but let's say you have this normal oscillator that we saw, the little PCB. You can build also yourself with this. Well, I have these from AliExpress, little oscillators, also overnight, temperature controlled, and these are actually pretty stable. But you don't need to build it yourself, because I found on eBay a seller, and it turned out to be Steve from the Digimode adapters. If you are him, you have an older radio and you want to do digital mode, you can have those digital mode adapters, fully isolated, proper stuff. But I found that Steve also made these for this whole 1990 series. So if you want a proper oscillator because it is broken, you don't need to do that yourself. You can just order it. I will leave a link. And I mention this because Steve is a viewer also of this channel, and Steve donated Rapco, if you remember, xggcoms.com, I think. I will leave a note just as a thank you. Okay, it is running now half an hour. It is still good, so I will not touch it. I will run it now on external reference, so I will switch this one off, and then we can see if we can find the limit again, because up to 1.3 gigahertz, but probably it can go also to 1.6. We saw that before, so let me find the correct connection for that. External arm, external ref, so that should be this one. Let me see if it also responds. Do we have indication if we use that? Do we have a light somewhere? Yes, here, external light. So when I plug it in, can we see that? Then this light should go on. Here, this one. Yes, it switches on, and of course, spot on. Okay, let's get one of the oscillators. I like this one because it is big. Power. This one also needs to be external reference. Okay. Then we get this channel. Okay, let's first do the A channel. I think I need to switch modes. Channel 1, 1K. Well, I can do a little bit more. Okay, 1 megahertz. Can we see that? Exactly, I would say. Let's do a little bit more. This one should go up to 160. That is the nice thing, if everything runs on external reference. It is, let's go to 100. And look at that. Does it go to 160? 170 even. 180 is still possible. 190. 200. Okay. Well, it says that it goes up to 160, I think, but it can do a lot more. So let's, yeah, I can do a little bit more, but no. So it's 200. Okay, no problems. Let's go to the 1600. Can he do that? No, 1.3 it was. No, it is missing 1.4. Yes, 1.4. So it's 0 dB. It goes up to 1.4 instead of 1.3 as they say. So that is perfect. Now, what if we put a little bit more signal? Maybe we can go higher because it's just a sensitivity issue sometimes. Let me check. Well, the smaller one was also 0 dB, but I see here that I can maybe adjust. Yes, I can. So what if I put a little bit more? How much can I do? 10 dB extra. 10 dB extra. And go higher then. 15. No, so it's really the prescaler then. Okay, is that is out of the way. Okay, that is interesting. While this counter is more modern, especially the prescaler looked better. It was all better encapsulated with grounding and little cans. And but in the end, it is limited to 1.4. And I think with the 1992 counter, we went to 1.6 if I remember correct. But well, they are both made for 1.3, so it doesn't matter too much. So Racal 1998, we saw the inside. It is adjusted as good as we can, but we are below the hertzes, so that is perfectly fine for me. And mostly I will run them external references. Everything here is run on external reference. And well, if you are interested in the 1992, I will leave it in one of the boxes in the corner. And yeah, they look very similar. And yeah, this is just one digit extra, and I like it. Thank you for watching, and I hope to see you next time.